Good day everybody. Today we have a beautiful integral question. Integral 0 to 1 x to the power of 3 negative x squared negative 1 divided by x squared negative x negative 1. Now this is degree 3, this is degree 2. So the degree of the denominator is lesser than the degree of the numerator. And because of that fact, what I wish to do is I would like to first divide the numerator by the denominator. So foremost, let me give that beautiful word, consider this integral, and what we will do is we will write down the numerator x to the power of 3 negative x squared negative 1 and the denominator x squared negative x negative 1. Now clearly I need to have x cubed, so I place the x there. X into x squared is x cubed negative x squared negative x. So change of sign, this is plus, you change it to negative, negative, positive, negative, positive. So clearly this can be cancelled. You have a negative x squared and positive x squared. This can also be cancelled. And then you have a negative 1 and a positive x. So just place that negative 1 and positive x. This is the remainder. So what we can do, therefore, when x to the power of 3 negative x squared negative 1 is divided by x squared negative x negative 1, we get the quotient followed by x negative 1, the remainder divided by the divisor x squared negative x negative 1, right? So this is the first step, and once we get the first step, everything would be alright, everything would be simple. So I'm going to write this down. Therefore this is all done for understanding. X to the power of 3 negative x squared negative 1 divided by x squared negative x negative 1 times dx. 0 to 1 is rewritten as integral 0 to 1 x positive x negative 1 divided by x squared negative x negative 1 times dx. This can be rewritten as integral 0 to 1 x times dx positive integral 0 to 1 x negative 1 divided by x squared negative x negative 1 times dx. This is simple to integrate, but I'm not much bothered about integrating this. This is a cakewalk. But let us consider this. So what I wish to do is, let me start by writing this. We will now consider integral 0 to 1 x negative 1 divided by x squared negative x negative 1 times dx. Now what I wish to do is I would like to rewrite x squared negative x negative 1 as a perfect square. So that means this is equal to x negative 1 over 2 raised to the power of 2. So when you expand this, you get x squared, the first term, negative 2 times x divided by 1 over 2, that's the second term, and you get 1 over 4, but you need negative 1, right? So that 1 over 4 has to be converted into negative 1. So how are we going to do that? So let me just show you that. So we got a negative 1, positive 1 over 4, and I want a negative 1. So if I were to add negative 5 over 4, this is going to be 1 negative 5 divided by 4, which is negative 4 over 4, which is negative 1, right? So just add to counter that 1 over 4, or to change that 1 over 4 that we are getting into negative 1. What I'm going to do is I'm going to add negative 5 over 4. This is going to be a standard for equations of this form. So let's go back. So this is equal to integral 0 to 1 x negative 1 divided by x negative 1 over 2 raised to the power of 2 negative 5 over 4 times dx. So this is what we have got. Now what we can do is we can make some substitutions. So I'm going to take, let x minus 1 over 2 be equal to some p. Now you got x negative 1, but I'm taking a substitution as x negative 1 over 2, right? Now if I were to differentiate this, I would get dx is equal to dp. So dx is taken care of. Now x negative 1 over 2. Can I write x negative 1 over 2 as, in fact, I want to write x negative 1 in terms of x negative 1 over 2. So can I write x negative 1 as x negative 1 over 2 negative 1 over 2? Fair enough, right? So x negative 1 over 2 can now be replaced with p. So you get p negative 1 over 2. So in place of x negative 1, I'm going to substitute p negative 1 over 2. So let's do that. I will come back to the limits within a minute. So in place of x negative 1, I'm going to substitute p negative 1 over 2 divided by, in place of x negative 1 over 2, this is going to be p squared negative 5 over 4. So this is what I got. So into dp, right? Now you can split this. You can split this in this fashion, in the following fashion. So this can be rewritten as, now let me come back to the limit. So when x is equal to 0, I get negative 1 over 2. When x is equal to 1, I get 1 over 2. Okay, so this can be rewritten as integral negative 1 over 2 to 1 over 2 p over p squared negative 5 over 4 times dp, followed by negative 1 over 2 integral negative 1 over 2 to 1 over 2 dp divided by p squared negative 5 over 4. So this is what we've got. Now I'm going to use a very important property for integration. Now if you have a limit negative a to a f of x dx, if f of x is odd, then this thing will be equal to 0. So clearly you can see this is odd. This is degree 1, this is degree 2, but numerator, the degree of the denominator is of little importance. It won't have any impact at all once the degree of the numerator is 1. So this is going to be an odd. Because the limits are stretching from negative 1 over 2 to positive 1 over 2, this vanishes. So we are left only to deal with this. So this is simple. So let us move to the next page and write the integral negative 1 over 2 integral dp divided by p squared negative 5 over 4. So clearly this is an even function. So I'm going to write it as 0 to the limits 1 over 2. There should be a multiple of 2. So let me place the 2 there. So this 2 gets cancelled, giving me negative integral 0 to 1 over 2 dp over p squared negative. Now 5 over 4, I can write this as root of 5 divided by 2 raised to the power of 2. Now I can use the logarithmic formula here, but I will do this by partial fractions. This is similar to integral dx over x squared negative a squared, which is nothing but integral dx over x negative a times x positive a. So by this fact, I can rewrite this as negative integral dp over p negative root of 5 divided by 2 times p positive root of 5 divided by 2. So let me consider 1 over p negative root of 5 divided by 2 times p positive root of 5 divided by 2. I'm going to rewrite this as a over p negative root of 5 divided by 2 positive b over p positive root of 5 divided by 2. If you cross multiply, you get 1 is equal to a times p positive root 5 divided by 2 plus b times p negative root 5 divided by 2. Let me take p to be equal to root of 5 divided by 2. If I take that, this vanishes, so I get only this. So 1 is equal to a times of root of 5 divided by 2 plus root of 5 divided by 2, which is a times LCM is 2, and you get root of 5 plus root of 5. You add these two, you get a times 2 times root of 5 divided by 2. 2 gets cancelled. So you get a times root of 5. On the left you got 1. Therefore the value of a is 1 over root 5. So this is for a. Now let me take p to be negative root of 5 divided by 2. This will vanish, this will remain. So you get b times of negative root 5 divided by 2, negative root 5 divided by 2. This is going to be, take the LCM as 2. This one will give you negative 2 times root of 5 times b, and 2 gets cancelled. Therefore, the value of b is negative 1 over root 5. So you got b, you got a. So if you were to take this as 2, therefore you can rewrite 2 as 1 over p negative root 5 over 2 times p positive root 5 over 2 is equal to 1 over root of 5 divided by p negative root of 5 divided by 2 positive negative 1 over root of 5 divided by p positive root of 5 divided by 2. You take this and you substitute it over here, right? So if I were to take this as 1, I need to go to the next page. So therefore 1 is rewritten as, so integral negative dp divided by p negative root of 5 over 2 times p positive root of 5 over 2 is equal to integral, my a is 1 over root 5 divided by p negative root of 5 divided by 2 times dp. My b is negative, so negative into positive will become negative. So integral 1 over root of 5 divided by p positive root of 5 times dp. Okay, so what we can do is we can take we can bring in the negative sign if you want, or else it doesn't matter, we can simply integrate this. So this is equal to, let me keep the negative sign, I take 1 over root 5 out, so integral dp over p negative root of 5 divided by 2 negative 1 over root of 5 integral dp over p, this is by 2, p positive root of 5 divided by 2. So this is what we've got. Now the limits, they stay as it is, right? We don't have to, we have just used partial fractions to disintegrate this. So the limits 0 to 1 over 2, they stay as it is. So I will place the limits as 0 to 1 over 2, 0 to 1 over 2. Now if you were to integrate this is going to be straightforward integration. There won't be any change at all, because this is similar to dx over x negative a, which is nothing but ln of x negative a plus c. That's what you would get. So there won't be any impact in this case. So negative 1 over root of 5, when I integrate this, I would get ln of p negative root of 5 divided by 2. The limits are 0 to 1 over 2. Okay, that's the first case, followed by negative 1 over root 5. The limits, if you integrate this, you get ln of p positive root of 5 divided by 2, and the limits are 0 to 1 over 2. So we've got this. What I would like to do before applying the limits, I will take 1 over root 5 out. So negative 1 over root 5. Then I'll apply the limits now. Okay, let me rewrite this. This is ln modulus p negative root of 5 over 2. The limits are 0 to 1 over 2. Negative ln modulus p positive root 5 over 2. The limits are 0 to 1 over 2. Okay, so this is negative 1 over root 5. I apply the upper limit. This is 1 over 2 negative root 5 over 2 followed by a negative sign. I apply the lower limit. I get negative root 5 over 2 followed by, I apply the upper limit. I get ln 1 over 2 positive root 5 over 2, and this is followed by a negative sign. So there is also a negative sign here, so that would mean this is a positive value, followed by ln root of 5 over 2. So this is what I have got. Now what I wish to do, I would apply the modulus operation to this value, so that would mean this would become positive root of 5 over 2. But there is a negative sign, and that would get cancelled with this. So we have got 1 over root 5. Now what I wish to do, I would like to bring in the negative sign inside. If I were to do that, this would become ln modulus of 1 positive root 5 over 2 followed by negative ln 1 negative root 5 divided by 2. So this is what we have got. Now if you remember, we started right from here. We considered integral 0 to 1 x negative 1 divided by x squared negative x negative 1 times dx, and then we went on. And this is the integration that I have shown you, right? Apparently because of the evenness, this would become 2 times 0 to 1 over 2. So the 2 will get cancelled with the 1 over 2, leaving us with this quantity, which I have split as p negative root 5 over 2 and p positive root 5 over 2, because this is similar to x squared negative a squared, and this would give me p squared negative root 5 over 2 raised to the power of 2, and that is exactly this. Now this has been split by partial fractions, and then I have got the value of a and the value of b, and I have substituted them, and then we were supposed to integrate that, right? So I've shown you how to integrate that, and subsequently we have got this value. Now what we need to do is we need to take this value and place it over here along with this. So that's what exactly I'm going to do. So therefore alpha is rewritten as integral 0 to 1 x dx plus 0 to 1 x negative 1 divided by x squared negative x negative 1 times dx is equal to, this is x squared over 2, 0 to 1 positive, this is 1 over root 5 ln modulus of 1 positive root 5 divided by 2 followed by negative 1 over root 5 ln modulus 1 negative root 5 divided by 2. So this is rewritten with 1 over 2 positive 1 over root 5 times ln modulus 1 positive root 5 divided by 2 negative. Now you can apply the operator modulus and then rewrite it, but I will just rewrite it, or I would say I will just retain it as it is. So this is negative 1 over 2, I should say 1 over root 5 ln modulus 1 negative root 5 over 2. So this is the final solution. Now having given you the final solution, what I wish to do is I would like to show you what happens if we do not use partial fractions. See, I would like to show the integration of this quantity without the use of partial fractions. So actually we have got negative 1 over 2, negative 1 over 2 to 1 over 2 dp divided by p squared negative 5 over 4, right? So this can be rewritten as negative 2 times 1 over 2 integral 0 to 1 over 2 dp divided by p squared. I'm going to rewrite 5 over 4 as root 5 over 2 raised to the power of 2. Now we can apply trigonometric substitution. So what I wish to do is I will say let p be equal to root of 5 divided by 2 times sine theta. So that means dp is equal to root of 5 divided by 2 times cos theta d theta. So if I were to substitute 0, now you can make the substitution, but the limits will be a little bit complicated. So I will just retain it as it is, just for the time being, and then I will simplify it later. Now what happens to this? This is negative. I'm not going to place in the limits. So dp, in place of dp you got root of 5 over 2 times cos theta d theta divided by p is root of 5 over 2 squared times sine theta, right? Sine square theta negative, this is going to be root of 5 over 2 whole squared. Now what we can do is we can actually take the negative sign out, and if I were to take the negative sign out, this will become positive. So I will place root of 5 over 2 here. So cos theta d theta divided by root of 5 over 2 whole squared negative root of 5 over 2 whole squared times sine square theta. This is what we get. So if I were to take root of 5 over 2 squared out, this would give me 1 negative sine square theta, which is nothing but cos square theta, and root of 5 over 2 whole squared. So I can flip this. So that would give me root of 5 over 2 times 2 over root of 5 raised to the power of 2, right? So for sure this can be cancelled and one of these things will be lost, times cos theta d theta divided by cos square theta, which is 2 over root 5 integral 1 over cos theta is secant theta d theta. This is what we've got. So what we can do is we can actually apply the integration here. So this is 2 over root 5. When you integrate secant theta, you get ln secant theta plus tan theta. This is what you've got. Now I need to place the limits, right? Now come back to this point. Let p is equal to root of 5 over 2 sine theta. This is what we have got, right? So from here I can actually extract the value of sine theta, right? It's possible for me to extract the value of sine theta. How? Now when p is equal to 0, let me show you that. When p is equal to 0, what happens? You got 0 is equal to root of 5 over 2 sine theta. Therefore sine theta is equal to 0. So the lower limit is 0 here. Now p is equal to 1 over 2. So what happens here? That means 1 over 2 is equal to root of 5 over 2 times sine theta. So 2 will get cancelled. Therefore sine theta is equal to 1 over root 5. Now draw the right triangle. And this is theta. Sine theta is opposite over hypotenuse. If I were to take this as ABC, I get AB squared plus BC squared is equal to AC squared. AB squared has to be obtained. BC squared is 1 squared. That's 1. AC squared is 5. Therefore AB squared is 5 negative 1, which is 4. Therefore AB is equal to 2. So I've got AB. Now I need secant theta, right? Secant theta is 1 over cos theta. Therefore cos theta is 2 over root 5. Therefore secant theta is equal to root 5 over 2, right? So over here we can write 2 over root 5, okay, ln, I don't have much space, so ln secant theta is root 5 over 2 plus tan theta. Now what is tan theta? Tan theta is sine theta over cos theta. My sine theta is found to be 1 over root 5. Cos theta is found, you can clearly see I've shown you here. Sine theta is 1 over root 5, cos theta is 2 over root 5. So this is 2 over root 5. So you flip it. 1 over root 5 over 2, they get cancelled, you get 1 over 2. So tan theta is 1 over 2. So this is going to be 1 over 2. And this is for the upper limit, right? For the upper limit, you can substitute this and you can rewrite this as 2 over root of 5 ln, you got the modulus, root of 5 over 2 positive 1 over 2. This is for the upper limit, right? Because we have not extracted theta. Theta in this case, if you had to extract theta would be sine inverse of 1 over root 5. That would be the value of theta here. But I have not placed in the value of theta. So instead of placing the values of theta, I have just extracted the values of the secant theta and tan theta for the upper limit minus the lower limit. Now if you had to put the lower limit is 0, right? So you have secant theta of 0. Now what is secant theta of 0? That is going to be 1 here, and this is going to be 0. So the lower limit totally vanishes, leaving us only with the upper limit. So this is what we have got when we integrated this. Right? So this has to be taken and substituted over here, right? So therefore when you substitute that, what do you get? So this is equal to, so this implies I am taking alpha is 0 to 1 x dx positive integral 0 to 1 x negative 1 divided by x squared negative x negative 1 times dx. So if you integrate this, you get x squared over 2, limits are 0 to 1. This quantity is 2 over root 5 ln modulus root of 5 plus 1 divided by 2. So this is equal to 1 over 2 positive 2 times root 5 ln modulus root of 5 positive 1 divided by 2. So this is the solution when we use trigonometry. But my question is, I have a question. When we used partial fractions, we got this. This is what we've got. So my question is, why did we get this? Right? Why did we get this? And if we have got this, is it possible to convert this to this? Right? So this will be the solution. But we are while using partial fractions, we have got this. Now I have posed the question, why this happened, and is it possible to convert this to this? Thank you everybody, enjoy your day.